Okay. Now, if you remember yesterday, yesterday I introduced mutually exclusive events, and I told you that if two events are mutually exclusive, it means they cannot happen at the same time. Now, complementary events are also events that cannot happen at the same time, which means complementary events are mutually exclusive. I'm going to repeat that. Mutually exclusive events cannot take place at the same time. Complementary events cannot also happen at the same time, which means complementary events are mutually exclusive. The only difference is that the probability of mutually exclusive events, okay, if you add them, they won't give you a 1 if the events are mutually exclusive. But if they are complementary, if you add the probabilities, you always get a 1.
Complementary events are mutually exclusive,
yes,
but mutually exclusive events are not complementary.
Yes, yes. You have to digest that. Okay, so complementary events are mutually exclusive, but mutually exclusive events are not complementary. Okay, now the equation for complementary events is this one here. Probability of A plus probability of B will always be equal to 1. Okay, so if two events are complementary, like example, the probability of it not raining today, maybe it's about 80% here at Kingsway, all right? Which means the probability of raining it will be about what? 20%. So if you add 20% plus 80%, you get 100%, which is the same as a 1. Remember, I'm not sure if this class was the grade 11. I wrote this yesterday. 0 is less than, remember, the probability of any event lies between 0 and 1, isn't it? If you write it as a percentage, the probability also lies between 0% and 100%. But when you do calculations, you don't have to convert every time a probability to a percentage. Remember, I told you yesterday, and I'm going to emphasize that. Probabilities can be written in 3 ways. You can write it as a common fraction, you can write it as a decimal fraction, you can write it as a percentage. If the question that does not specify and the answer can be written as a common fraction, you just leave your answer as a common fraction. If it can't be left as a common fraction, you can then convert it to a what? A decimal fraction. But a percentage, you can only convert to a percentage if the question asks you to do so. Okay, so your complementary rule, probability of A plus probability of B is equal to 1. Right? Now, sometimes we may represent this probability of B or that probability of A by not B or not A. So I can rewrite this PB as probability of not A. What this means is the probability of B will be the same as the probability of not A. And then we also use the prime as well, whereby we can replace this probability of B by probability of A prime. So probability of B is the same as probability of not A. They are both the same as probability of A prime. Is the notation. Is the notation. Okay? Two events, A and B, right? Probability of A plus probability of B will be equal to 1. Probability of it raining today is about 80% plus probability of it not raining, that will be 20%. Add the two, you convert the probabilities to a common fraction, you get a what? A 1. So this probability of B, we can call it probability of not A because 1 minus probability of A will give you probability of B, isn't it? But probability of B is the same as probability of not what? Of not A.
What is the second one?
Which one? Okay, this is another probability notation. It's a prime, it's like an apostrophe. Okay? Alright? So it's A and it's like a 1 on the top right hand side of the A. You might see it, but don't stress about that. Okay, but you might see, if you see it in the paper, please be aware that this is the same as not A. Okay, if it's not A, then it's equal to what? E. The same, that's why I'm writing them. I wrote them there. They are exactly the same. It's the same notation. Even the meaning is the same. But what I would suggest is, obviously, you see here, probability of A plus probability of not A is equal to 1. This probability of not A is the same as probability of B. Okay? Then I can calculate probability of not A by subtracting probability of A from 1. That's common sense. Because if the probability of it raining today is say 4 over 5, it means the probability of it not raining would what? 1 over 5. How do you get the 1 over 5? You subtract the 4 over 5 from what? From 1. It's basic maths.
So sir, is this always when you have two events that
Whenever
happen?
you that are complementary. If two events are what? Are complementary.
So basically the two events fill the sample space.
Yes, yes, yes. The two events, they fill the what? The sample space. Thank you for that. Are you following that? It's not that difficult. Okay, so we've got some examples here. Okay, speaking English every day in everyday conversation. You can speak English every day in your conversation. Or you might not what? Speak English every day in your conversation. Right? You can walk to school on a Monday, or you might not walk to school on a Monday. Those are some of the examples. Right? If you toss a coin, you can get a head, or you might not get a what? A head. And then if you roll a dice, you might get maybe a 3, or it means that the remainder will not be a what? A 3. Also, the raining one, which I just illustrated to you, the probability that it will rain today at our school, maybe it's 90% today, which is 9 over 10. What is the probability that it might rain? 1 over 10. How do you get the 1 over 10? It's 1 minus 9 over 10, which gives you what? 1 over 10. There is no reason to be scared if you see this. It's just playing around with one equation and making either probability of A the subject, or making probability of not A the subject, or probability of B the subject, or making 1 the subject.
Now, so would it be right to say that the probability of A is also the probability of not B?
The probability of A is also the probability of not B, yes. So we can write probability of A, okay, is the same as probability of not B, which means that will become a probability of B prime. Not B is the same as B prime. Remember, every topic in maths has got its own what? Notation. Every topic in maths has got its own notation. Are you following? Okay, so allow me just do some examples. Now, just to summarize this, okay, just to do a summary. So, I started with the addition rule. Number one, addition rule. This is just a summary piece of what I introduced yesterday. And can you stop that? The addition rule, probability of A or B is equal to probability of A plus probability of B minus probability of A and B. That's the addition rule. Okay? This is the addition rule. When you come to your maths paper 1 in November, then you make sure you know this. Okay? Don't take a risk of coming and you don't know your addition rule. Then number 2, you have got mutually exclusive events. Mutually exclusive events. Remember, there are 2 events that cannot take place at the same time. So the probability of A or B is always equal to the probability of A plus probability of B. Probability of A or B is equal to the probability of A plus the probability of B. Then the complementary rule. So with the complementary rule, I can write it in 3 ways. Okay? So we can write it as probability of A plus probability of B is equal to 1. Or we can write it as probability of A plus probability of not A is equal to 1. Okay? This you can also, well, you can make probability of A the subject, probability of not A the subject. You can also do it for probability of B as well, where you say probability of A is the same as not B or B prime. Are you following that? So let me use another color to just write. So probability of A plus probability of A prime is equal to 1. I'm using the different notations. I'm doing that because I don't want anybody, when you see a question with A prime, then you say, what is this? I'm telling you now that probability of B is the same as probability of not A is also the same probability of A prime. Alright. So let's just answer some questions on how to use these 3, okay, I would say equations. Right? Let's answer some questions. So let's move on to examples. Is there anybody who has got a question before I move on? Okay, so this is a typical examination type question. It was from a common paper from 2015. Okay, So according to the question, it says probability of A is 0.6, probability of B is 0.3, probability of A or B is 0.8. Okay. Now, after I've shown you this example, please don't be scared if you see a question like this. And I'm saying this from experience because some learners, when they see a question like this, the brain shuts down. This is a very, very easy question. It's a very, very easy question. So the question says, are the events A and B mutually exclusive?
No.
Okay? Then you need to justify your answer now with appropriate what? Calculations or a diagram. Okay? Now, in my case, I prefer to do it using the equation for mutually exclusive events, because that is the easiest approach. A. So to answer this, first let's write the equation for mutually exclusive events. Its probability of A or B is equal to probability of A plus probability of B. Okay? So what this means is, if the two events are mutually exclusive, the probability of A or B, which is 0.8, must be equal to the sum of the probability of A and the probability of what? Of B. That's how easy it is. So we'll just substitute. So this is 0.8 given. There is no need to have an increase in heartbeat or in terms of substituting P, A, or B. It's given there. This value here. That's the probability of A or B. You just substitute it. Then the right hand side, probability of A is 0.6 plus probability of B is 0.3. So if you do the calculation, you find that you have 0.9 on the right and you have 0.8 on the left. Are they equal? No. So you put a non-equal sign there. Then once you do that now, then you conclude now and say, therefore, the two events are not mutually exclusive. Are not mutually exclusive. Okay? Then you can give a reason and say because probability of A or B is not equal to probability of A plus probability of B. Yeah, you can give you probably have to give a reason. We'll say just by your answer there. Are we following that? The two events are not mutually exclusive because the probability of A or B is not equal to the probability of A plus probability of B. Okay, so this is like method 1. You can also use the addition rule as well.
This is a 4-mark question.
Yeah, it's a 4-mark question. So you get 1 mark for the equation, then you have substitution, then for getting that in the conclusion. Any question?
So when they ask the question, will they always give you like a hint of which equation to use? So there it asks you, are they mutually exclusive? So you use that one.
Okay. I forgot to put here are not. Someone was supposed to tell me that say you didn't put not if they are not mutually exclusive. Okay, I forgot to put that there. They are not mutually exclusive. So if for that for saying they're not mutually exclusive, that's 1 mark. Then you also have the working out.
Now I'm saying like when they ask the question, will they ask you to like, will they say, are they complementary or are they mutually exclusive?
No. Okay, normally the question when it's asking either it's straightforward about mutually exclusive events only. It's very rare to get a question on asking to to prove or to justify that the two events are what? Are complementary. Okay. But you might get that. So how do you prove that the two events are complementary? When their sum is equal to what? To 1. The sum of their probabilities is equal to 1. Okay. Please just get this. Okay. I said it when I was talking, but I forgot to put it there. Right. Any question? Normally you get a question on mutual exclusive events. Right. But sometimes, like here, this question, we are now talking about what? Complementary. No, complementary events. Right, so 9.2 says for any two events A and B, it's given that the probability of A and B is 0.12, probability of A of B is 0.83, the probability of B is equal to 4 times the probability of A. Can you do quickly? All right. So the first question now says, are events A and B mutually exclusive? And then it says justify answer. It is only 2 marks. Now if you compare this question and this one here, this one has 4 marks, but we don't have too much information given as compared to here. So the easiest approach will be to look at this. What do you know about the probability of an intersection if two events are mutually exclusive? From yesterday's lesson. The probability of the intersection will be what? 0. So for this question here, your first answer here will be what? No. Then you say because probability of A and B is greater than what? 0. And then you get your 2 marks. So by saying probability of A and B is greater than 0, you are saying it's not 0, therefore the two events are not what? Mutually exclusive. So that would be the shortest way. If you don't want to do that, well, you can take the long route of writing the equation for mutually exclusive events, but that will take you more time. Because you've got A or B. Unfortunately, you don't have probability of A direct and probability of B direct. So you might have to use these two, and that will complicate things for this question. So it's just better to use this equation. Probability of A and B is equal to 12, which means it's greater than what? 0. Therefore, the two events are not mutually exclusive. If they were mutually exclusive, then the probability of A and B was supposed to be what? 0. Are you following them? Huh? Hello? Okay. Then calculate PB. Okay? Now, to calculate PB, it's 4 marks. This tells us that you need to do a bit of some working out. Okay. Over the past few days, I was marking a metric paper. There was a question which was almost like this, which came in the metric paper, because this is tested in metric. Right? And it's not difficult at all. Right? Now, if you want to calculate the probability of B here, it's better to start with the addition rule. Okay? The good thing about the addition rule is that it also incorporates what? Mutually exclusive events, when the probability of the intersection is 0. So to answer this question here, I'm going to start by saying probability of A or B is equal to probability of A plus probability of B minus probability of A and B. That's where I'll start. Okay? Then you substitute. There's no need to be scared. No reason for your heartbeat to increase because you solve this question. It should be easy. You should be smiling when you see it. So the probability of A or B is given as 0.83. You just substitute it. The probability of A is it given? But we are told that probability of B is equal to 4 times probability of what? Of A. What does this mean? Which one is greater, the probability of B or the probability of A? Probability of B, right? We want to calculate probability of B. Okay, to avoid complications in terms of working with fractions, right? Where there is probability of B there, I'm going to put what? 4 times probability of A. Can you look, please? So I'll write here probability of A, but probability of B can be written in terms of probability of what? Of A. It's written here, probability of B is equal to 4 times probability of A. So I'll put here 4 times probability of A. This question, it's almost exactly as the one which came in the trial paper. And in most of the matric learners, they could not do it. But yet it's a grade 10 question, like your sister should be able to teach you this. Yes. Fortunately, I think she got this right. Fortunately. So, it's 0.12. What are we going to do here? We're going to... Which 0 are you talking about? P and B is given. Given is 0.12. So this becomes 0.83 is equal to 5 probability of A. Do you see that it is 5 here? We have got 1 here plus 4. There is no need to get scared and to add them the correct way. It's 1 plus 4, 5 P minus 0.12. Your knowledge of equations. When you take minus 0.12 to the left, you will get 0.95. That's equal to 5 times the probability of A. So, the probability of A will be equal to, it's going to be equal to what? 0.19. Right. Now, this is not the final answer, by the way. We want the probability of what? Of B. So, we will say, therefore, the probability of B is going to be equal to 4 times 0.19. Okay? I hope you are following where I'm getting the 4 times 0.19. It comes from this equation. Okay? So if you multiply that, you get 0.76. So that's the final answer. That's the probability of B, 0.76. Are you following? Then the next question now, it's on complementary group. Okay, because we have got this not A. So the probability of not A, this is so easy, is equal to 1 minus the probability of A.
You have to say that you not just say P not A is equal to PB.
Yeah, I can do that too.
So then you don't need the whole.
Yeah, it's also the same as probability of what? Of P. But you see, here you can end up having a problem. I would suggest that you work with A throughout. Don't try to introduce B because you can end up making confused because there are two different events. The probability of B not happening, it might not be exactly the probability of A happening. Okay? So if it says P not A, if you pay attention, P not A, it means this would be equal to 1 minus probability of A. Yeah, this is the complementary rule. The moment you see not or A prime, right? So, I went too far. So here, the probability of not A is equal to 1 minus the probability of what? A. What's the probability of A? 0.19. So this will be 1 minus 0.19, and that will be equal to 0.81. Okay.
Oh, that's why you can't just do that.
Yeah, you can't just say it's equal to probability of B. It's better to work with not A and with probability of A together. Because what happens that probability of not A, sometimes it is possible that it might also include B plus something else with plus A. So and then you can end up with the one in total. But it's better to just work with not A and probability of A. Okay. So that's it.